Hi, my name is Austin McGlashan. Welcome to my motion analysis presentation to explore the motion of backflips. First, we'll look at the math, then we'll jump into analyzing some flips. Two important assumptions I've made are there is no force exerted by air on the person and conservation of angular momentum. I'll mention the rest later on. To find the height of the jump, a simple kinematics equation is used. Angular momentum is conserved during the jump. However, moment of inertia decreases during the tuck portion, and thereby angular velocity increases. Because of this equation represents the average angular velocity during the whole jump. Here, the initial takeoff velocity is found through both conservation of energy and kinematic equations. There's uncertainty in finding the force of the jump because it's assumed the legs push through 1 foot, and the mass of an average male gymnast is 150 pounds. Additionally, all flips shown are done on a spring floor, and this force is included in the jump force. This calculation has the most uncertainty. To find the velocity of head and toes during the horizontally tucked position, I assume them to be 2 feet from the axis of rotation. In summary, for each flip, we'll find the height, average angular velocity, takeoff velocity, force of the jump, and velocity of the head and toes. Okay, we're going to fly through these flips here. In this standing backflip, I got 0.63 seconds of airtime with an angular velocity of 1 radian per second. When I added a roundoff, I got 0.66 seconds of airtime with average angular velocity of 9.5. This backflip highlights the importance of technique as you got 0.8 seconds of airtime and only needed 7.8 radians per second. This flip has the same airtime as the previous, but his average angular velocity doubled to 15 radians per second. In a round-off triple backflip, this gymnast got an incredible 1.13 seconds of airtime. Going almost 26 feet up in the air, this person was flipping a little more than 3 flips per second. In our last flip, this gymnast was airborne for 1.38 seconds, reaching an astonishing 7 feet 8 inches off the ground. Here's a summary of all the flips, and that's all I have time for, everyone. Goodbye.